Why does the vacuum seem to have fields everywhere, yet feel like there's nothing there? In the energy filament theory, the vacuum is far more than just an empty space. It's a vast, dynamic sea of energy that is stretched tight, yet appears calm on the surface. The moment you touch or interact with it, it immediately responds, as if saying, "I'm here." One of the clearest examples of this phenomenon can be seen when you place two metal plates very close together, with nothing in between. To the naked eye, it looks like an empty gap, a vacuum. But with precise instruments, you'll notice that the plates actually pull towards each other, as though an invisible hand is pulling them in. This is the energy sea reacting. You've disturbed my rhythm, and now I must adjust to a more efficient, lower energy state. Let's consider another example. When a high-energy photon enters a super-strong electric field or passes near a black hole, what appears to be an empty region of space suddenly gives rise to an electron-positron pair. It's as if you stir calm water and suddenly whirlpools emerge. If the vacuums were truly an empty void, how could light somehow create structure and matter from nothing? Even more subtle effects occur in seemingly empty spaces. For instance, atomic energy levels might shift slightly, and the speed of light or its refraction might change minutely. It's as though the vacuum itself is involved in the process. This is what we refer to as vacuum fluctuations, tiny bubbles of energy that appear and disappear, briefly disrupting the vacuum. While these fluctuations might seem like random noise in individual cases, they left behind a very clear signature when observed over time. If the vacuums were truly nothingness, these effects wouldn't be possible. The clearer picture is this. What we call a field is always present in the energy sea, but most of the time, it remains evenly distributed and quiet, much like a perfectly flat mattress. However, when you place something on it, a metal plate, a charge, a current, or a beam of light, you're pressing a shape into the mattress. This causes the surrounding tension and textures to rearrange themselves, adjusting in response. This is how we observe changes in forces, shifts in energy levels, and even the creation of particles. The vacuum only seems empty because the field is uniformly distributed and calm, much like the surface of a vast ocean. From a distance, it appears flat and still, but as soon as something disturbs it, a boat passing, a stone being thrown, or the wind picking up, you suddenly realize that the water has always been in motion beneath the surface. Once you understand this, you begin to see that when we talk about electric fields, magnetic fields, gravitational fields, or quantum fields, we aren't introducing entirely new and separate concepts. We're simply naming different states or configurations of this underlying energy sea. In fact, these fields are just different ways the sea's tension, texture, and rhythm express themselves. In the next episode, we'll continue by exploring a fascinating question. How does this sea get tight and loose? Why does a tension map control the falling and orbits of everything in the universe? Tension fields, the topography of the sea's tightness. Tap follow, share it on New Physics, Clear Universe.